Hello everyone and welcome back. With this session, we're gonna take a high-level overview of NAT. Though NAT is not part of the big IB administration course, but as I said in the intro, I think it's important to have a high-level overview about the NAT that's happening on the big IB. Now, uh, by default and without any configuration, there are some changes on the source and destination that happen uh, through the traffic flow. Let me remind you that the big IB is proxy architecture, means there are two sides. We have the client side between the client IP and the virtual server, and then we have the server side between the inside interface of the big IB and the real server. So our client machine 100.15, when we type the virtual server IP address in the browser, we're actually opening a TCP connection between the client and the virtual server. Now, based on the load balancing method, the big IB will select one of the servers, and let's say it's server one. Then the big IB will open a separate TCP connection between its inside interface and the uh, the real server. However, this connection by default, big IB will spoof the client IP address. Though the connection is between the big IB inside interface and the real server, but the connection will be using the source IP address, the same source of the client, the same IP of the client. So let's trace this. So from client to virtual server, the source is 115, destination is 180. Now source port is random generated, anything be above 1024, and the destination port is 80. Now between the big IB LTM and the server, as we said, the LTM will spoof the client IP. It will open a new connection with the server using the client IP, the original client IP. The destination will be the selected server. Source port, random port, could be any port. Destination port is 80. Now, when the server responds, the source will be the IP address of the server, the destination will be the client IP address. This response will hit the big IB. Here, the big IB will change the source. It will be 100.80. So, because we are on the client side now, if you check the first packet, source 15, destination 80. So the response to this packet should be coming from 80. So when the LTM send the response back to the client, the source will be the virtual server, the destination will be the client itself. Let's see this on the lab. So if I open connection to the virtual server, if I check the connection table on the PC, the test PC, we should see that we have connection with the virtual server. On the client, we will never know about the subnet 10 because the big IB is acting as a full proxy. We see nothing behind the big IB by default. And now on the server side, I have Wireshark, so let's use the Wireshark to see what source IP address we are seeing on the server. So let's capture. Let me filter to TCP port 80. Apply the filter. Stop. Start again. The capture. And Before we open the web page from the client side, I can see HTTP traffic coming from the self IP, the inside IP address of the big IP. This is actually the health monitor, because remember on the pool, we did configure HTTP health monitor, which is probing the server. So we can remove this. The pool will become blue square, but it will still work. We will still be able to open the web page. Now we should see that this stream of traffic has stopped. Let's actually open the web page from the client test machine and see what we can see on the Wireshark. Refresh a couple of times. Go back to the Wireshark. Nothing. Let me open private window. Sometimes the browser behave very strange, so page didn't open. It should. The virtual server is not down. Status is unknown. Do we have anything on the server? Can we ping the server? Yep, we can ping. Can we telnet to 10.00.81 on port 80? Yes, we can. Is the default gateway on the server still valid? 10.0.0.1. So there has to be something on the client machine. Ping. No, we can ping. Yeah. So if we go back and open the application from the client, we should see the traffic on the Wireshark now coming from 100.15. So the source IP address remain the client machine, even it's a separate connection. It is between the big IP and the server, but the big IP will spoof the client machine. Now, in this scenario, I want to draw your attention to one point. Now, remember that the servers, the three servers, are configured with the big IP as a default gateway. This may not be the case all the time. It's not necessarily that the big IP self IP is the gateway of the servers. It may be the switch in the data center. It may be the firewall. Most likely it will be the firewall. It could be any other layer 3 device, but in most production environments, the big IP as a load balancer will not be acting as a default gateway. So let's go to the server 1, and let's say the default gateway is 254, which is the firewall, not the load balancer. Now, what's going to happen? What will be the impact on our testing environment? Let me open new private window, 192. It's not working. Let's go back to the Wireshark. Let's stop, start again, clean the view, and let's try to refresh again. What do we see on the Wireshark? We see traffic coming from 15 to 81. We don't see any response from 81 back to 15. We don't see any response from 81 back to 15. Now we can test again. So let me change back the gateway just to compare the capture. Let me stop the capture, start again, clean, view. Let's refresh the page. Now it will work. The page should work now. And we go check the capture. So we see SYN, SYN-ACK, ACK, HTTP request, HTTP response. So that's the normal flow. 15 sends to 81, 81 respond. Now, when we changed the gateway, made it the firewall, this is where the flow was broken. So let's clean the Wireshark one more time. Let's go to the testing machine, new private window, 192. So it will not work now. We go back to the capture. We should see something soon. It will take a few seconds to show up. Nothing showed up on the Wireshark. Let me open a new window. Yep. Now we can see on the capture traffic coming from 15 to 81, but 81 is not responding. Why? It's a routing. So the traffic coming from 15 to big IB is sending to server 1, but on server 1, the source IP is still 100.15 because the big IB is spoofing the 100.15, sending the traffic to 81. Now, on 81, we get the request coming from 100.15. Now, this IP address is not on our subnet. When we send traffic to an IP address not in our subnet, we have to send it back through our gateway. So 81 will try to send it to the gateway. Now, in our lab, the gateway does not exist. But even if the gateway does exist, and even if the gateway is able to send the traffic back to the client, if the server respond to the HTTP request via the gateway to the client will drop the traffic. Why? Because the client was talking to a web app on an IP address 100.80, and the response came from 10.0.0.81. So the client will say, no, I didn't ask for this traffic. This is not for me, and the client will drop it. So what do we do in this scenario? The big IB is doing load balancing for the servers, but the servers configured with the firewall as a default gateway. This is where the secure NAT comes into place. In F5 documentation, it's called secure NAT. More clearly, we can think about it source NAT. What is the source NAT? We will configure big IB that when you open a connection with the real server, use your IP address. So in case of single big IP appliance, use the self IP. If we have two big IP configured in cluster, there will be cluster IP, or they call it floating IP. If the floating IP is there, then the big IP will use the floating IP as a source. So when the big IP talk to the server, request the web page that the user already requested, he will not spoof the user IP, he will use his own IP. So when the big IP send the request to the server using his own IP, the server will respond back to the big IP, and the big IP will send it to the client. How we do that? It's actually on the virtual server, there is property called source NAT, OS NAT. We use for now automap. Automap means use your self IP. Automap means use the self IP of the interface. Again, if the appliance is configured as a cluster, it will use the floating IP, the cluster IP. Click update. We go back now to our testing machine. Let me first close all the windows. Let's open new one. And it's working again. It is working again. Why? Because the big IP, when the big IP contacted the server, it used its own IP. Let's close the capture, start again, clean, and let's refresh the request from the client. Go back to the packet capture. Now you see all the traffic is coming from 10.0.0.1. You see the HTTP GET request? It's coming from the source self IP of the big IP. We can confirm that with the command line tmsh show /sys connection client side client address 192.168.100.15. This is our user. Client timed out. Let's go back to the client machine and do a couple of refresh. Go back to the connection table. You see, from the client side, it's coming from the client to the virtual server. However, on the server side, it is now being sourced from 10.0.0.1, the self IP of the LTM. If you go back to the command line session previously, it was not being sourced from the big IP itself. It was being sourced from the client IP. We would see the 115 here and we would see 115 here. But now, because we configured source NAT on the virtual server, we told the virtual server to use the self IP of the inside interface when communicating with the server. This is what we call source NAT or secure NAT with the big IP. And again, for the show connection, you can use all the parameters. The objective is just to see the client side IP information and the server side IP information.